Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to Srinivasarao Sir classes. In this session, we are going to learn about routing and the types of routing. So, what is a routing? As we are learning the internet layer consecutive lectures, now routing is playing a very important role, especially in internet layer. So, what is the meaning of routing and what are the types of routing we will discuss in this session. Before entering into the session, our anthem is Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, we all know that Unacademy is a provided wonderful digital platform to serve the dedicated students, which are done by dedicated faculty members. So what you all need to do to access the dedicated content and the top quality content, just to get the admission from Unacademy and enjoy the sessions. Myself is Srinivasarao IS, having more than 15 years of experience in the GATE with the various papers. I also had industry experience in the back end as a database side and networking side with a good certifications. So achieving certifications require a lot of patience and confidence and training also. So you will get such kind of training just by taking an admission into an academy. So dear friends, throughout my journey of GATE, I taught in many premium academies with a high success rate. Many of my students settled in their respective positions in top quality. So just by clearing GATE examination, you also can achieve such kind of wonderful positions. So utilize this opportunity what the Unacademy is providing to you. There are two kinds of courses are there. One is iconic and the other one plus course. So plus course, once you take, you become a premium member and a plus student. You can access live lectures, live sessions and mock test. Whatnot, everything which is available in an academy portal, you can access unrestrictedly and clear your GATE examination. And the second variety of course is iconic, where you are going to see that the 1:1 personal coach program. So let us see that what are the subscription price. According to the plus, you mainly focus on either 12 months or 18 months and 24 months. It requires, because a GATE examination is a 10 subjects combination. So there is a need of a minimum of 12 months and maximum your wish. And if you apply my referral code, you are going to get a maximized discount. So use my promo code and get the maximized discount on the plus codes. Then these are the prices you are going to get once you use my referral code Sankara. So dear friends, the next variety program is Iconic Batch, where you see the two kinds of flavors, 12 months and 24 months. So my referral code is also eligible to this. So use my referral code, then you're going to get a maximized discount like this. Dear friends, let's crack GATE CSE is our YouTube channel. Subscribe our YouTube channel. Use my referral code to get the admission into Unacademy. Hit the bell icon for latest notifications and updates. Now we are going to learn a concept called one of the main responsibility or function of internet layer, which is nothing but routing. Before learning about routing, let us see that how your data can be forwarded, how your packet can be forwarded. There are three varieties of forwarding mechanism. One is a delivery system, the other one a forwarding mechanism, the other one a routing mechanism. So three mechanisms are there to push your data onto the network and finally it goes to the destination. So what is the first mechanism? Delivery. This is one of the responsibility of network layer, delivery mechanism. Second mechanism is forwarding the data. Third mechanism is routing the data. So let us see what are the different differences between delivery mechanism, forwarding and routing. Our ultimate aim is we want to send the data to the exact destination. So we are using three different varieties. What is a delivery? For example, you see that If receiver is immediately available next to me, then I will hand over to him. That is the meaning of delivery. There are two varieties of deliveries in that: direct delivery and indirect delivery. What is direct delivery? If a person belongs to my class and I can able to immediately hand over the packet to him, that is a delivery, direct delivery. If a person belongs to some other class, then I need to give you to the CR of the particular class and that CR will hand over to him. That is indirect delivery. But indirect delivery, the last destination delivery is nothing but delivery, direct delivery only. So, in indirect delivery, the last handing over mechanism is a direct delivery and bypasses is called as indirect delivery because they belongs to some other network. So, that is the meaning of delivery mechanism. What is a forwarding mechanism? We are trying to forward your data packet via different networks, subnetworks. That means destination is somewhere and your belongs to somewhere, and we are going to use the concept of routers. With the help of routers, we are trying to push your data packet from one particular network to other particular network. So we are forwarding. So forwarding is nothing but what? It is using the concept of a routing table. Right, understand carefully. In delivery mechanism, there is no, what I mean to say, routing mechanism. But in forwarding mechanism, there is a requirement of what? Routing mechanism. And advanced routing mechanism is nothing but your routing only. What is that? Your routing tables are frequently are updated in order to find the shortest path. Finally, your data will be handed over by comparing all the routing tables. Now, my dear friends, I am going to present the three varieties of delivery mechanisms. The first one is delivery. What is the delivery? It refers the way the packet is handled by underlying networks under the control of the network layer. There are two varieties of delivery mechanism. One is a direct delivery, the other one indirect delivery. Direct delivery means the destination belongs to your network. Indirect delivery means destination belongs to some other network. Let us see what is direct delivery. It occurs when the source and the destination of the packet are located on the same physical network, or the last delivery is also direct delivery only when the delivery is between the last router and the last destination host is also called as direct delivery. Without direct delivery, you cannot hand over the packet because the last ending point comes under into direct delivery. In middle, you can have bypasses. So the sender can easily determine if the delivery is direct. What is the meaning of that? It can extract your network address of the destination and compare this address with the addresses of the networks to which it is belongs to your destination got connected. If a match is found, immediately we are going to deliver the packet, right? This is about direct delivery. So listen carefully, direct delivery. So host A and host B are belongs to same network only. Therefore, host A can directly send the data to other particular host because both are belongs to same network. Okay. And what is indirect delivery? Let us see indirect delivery. If the destination host is some other network, it's not in the same network, some other network, then the packet is delivered directly because it is not available immediately in my next network. Therefore, my dear friends, the packet goes from router to router until it reaches to the destination path. So note that delivery always involves one direct delivery but zero or more indirect deliveries because the last delivery is always direct delivery only. And note that the last delivery is always direct delivery. So if you observe indirect delivery here, host A is a sender is available in one network and host B is a destination is available in second network, network 2 and network 1. Both are connected with a router. If both are available in single network, no problem. Same class, I can able to hand over the packet directly. But if somebody is available at some other class, I need to first of all search where he is available, then give him. That means I will give the data to my CR, and my CR will give the data to the other class CR, class representative. Then he is going to hand over the data to others. So indirect delivery is happening between your sender and the receiver, but last receiver is going to take a what? Indirect delivery only. So from here to here it is indirect delivery, but the last network, the destination whom it is belongs, it is a direct delivery only. Okay. So next variety is a forwarding mechanism. What is a forwarding mechanism? So forwarding refers to the way the packet is delivered to the next station. Okay. So forwarding means to place the packet in its route to the destination. Forwarding requires a host or a router to have a routing table. So now we are going to verify the path according to the routing table. So when a host has a packet to send or a router has a packet to receive, then it to be forwarded, it looks the routing table and find the route and give to the destination. This is about forwarding. There are two varieties of forwarding. Next to hop, next immediate forwarding, and network forwarding, and default forwarding. Default forwarding is nothing but we are believing on the router, and the router is going to use a default address. This is your default address, which is using by, also called as a default gateway, which is using by your router to forward your data packet. That means we will see that always one particular path is a default router. If other particular paths are not existed or failed, then immediately the packet will be gone to the receiver using a default method. Okay. And now let us check what is the next hop and the network specific. Next hop means, so sender is here and the router is here and the router is here and the receiver is here. So sender's next hop is this, and this guy's next hop is this. This guy next hop is this. Okay, that's the meaning of hop. Let us see. So to reduce the contents of the routing table is called next hop method. So the routing table holds only the address of the next hop instead of the information about the complete route. So we are not going to interest the complete route. Our main focus is who is the next to my immediate neighbor. I will give him, he will forward the packet to somebody else. It is a hop to hop exchanging of your packet. Okay. So the entries of the routing tables must be consistent with the other. What is a network specific? So we will hand over the packet to network only. Okay. So second technique is to reduce the routing tables and simplify the searching process is called a network specific method. So instead of having an entry for every destination host connected to the physical network, same physical network, we have only one entry that defines the address of your destination network itself. Let me say one example. So sender is here, he is forwarding the packet 1, and I want to push to multiple destinations. So you need to write those many times the destination IPs. Observe carefully. So instead of what I am doing, and these destinations are belongs to some X network. So I will use a destination address as X network only. So now sender packet consists destination address. Sender packet consists destination address. What is that? X network only. So whenever packet has come to X network, then this X network will pass the packets to all of them. So instead of writing 4 destinations or 4 routing table entries, just simply one routing table entry is enough to satisfy this. This is what about network specific. Otherwise, it is host specific. What is host specific? Destination address is this, destination address is this, destination address is this, destination address is. This is what is the meaning of host specific forwarding. And simply they are belongs to one network. I am saying that exactly I am hand over to other network, and that network is going to hand over to the nodes who are connected to that particular network. So let us see the diagram of it, host specific versus network specific. So this is your host specific. As there are 4 destinations are there, so you need to write 4 destination. Destination A I want to push, destination B I want to push, destination C I want to push, destination D I want to push. Because they are all belongs to network 2. A, B, C, D are belongs to network 2 and sender is belongs to network 1. So I need to write 4 entries, as I already told you here. I need to write 4 entries. So instead of writing 4 entries, I will write only 1 entry for network 2 because they all belongs to network 2 only. That is the meaning of network specific. So what I am doing, instead of writing A, B, C, D, I will write only 1 entry N2. And what is your it? My next hop is what? I am going from N1 to N2 using R1. R1 is your via between your N1 and N2. The example is, if a network 2 consists of thousands of IP addresses, if I am using host specific, I need to use those many entries. As they all belongs to a single network, what I am going to do? I just simply write the entry of the particular, what I mean to say, network, and that network is distribute the data packets to others. It is also a concept called hierarchical routing. Network specific also called as hierarchical routing. You can able to reduce the routing entries. Okay. So if 1000 hosts are attached to the same network, you don't write 1000 entries. 1000 entries you are writing means it is host specific. I am writing only one entry, that is the N2. They are all connected to N2 only. So I need to write only one entry instead of 1000 entries. So this is about host specific and network specific. The third variety is default forwarding. What is a default forwarding? So every particular router is going to follow default. What is your default address? 0.0.0. So instead of listening all the networks in the entire network, host A can just have an entry that is called default. The packet will go via default only. Listen carefully. So host A is the sender and there is a network 2. They are going via R1. Instead of remembering them R1, R2, for example, there is other network also R3, there is other node. And there is a other router is called R4, which is connected to network 5. So what I am going to do, I am using just a default router. Then default router automatically hand over the data to rest of the networks. So I am going to write only one entry. What is that entry? Default entry. Okay, my dear friends, it goes to any other destination. I am going via R2. Otherwise, you need to write entries like network 2, I am going via R1. Network 3, I am going via R3. And network 4, I am going via R4. Even though I am using network specific, please understand, even though I am using network specific, I want to transmit the data to all the networks. Therefore, I am using the concept of what? 0.0.0.0. It hand over the packet to the rest of the internet, belongs to all the networks. And the third mechanism is each and every routing entry table we are going to identify and see that optimal path before transmission of your data. That is the meaning of routing. So routing inbuilt has a delivery as well as a forwarding mechanism. Both are inbuilt in this. So it refers to the way the routing tables are created to help in forwarding. That's what I told you. What is that? Your forwarding and delivery are inbuilt or having a routing concept. So we are performing a routing protocols to find the shortest path in order to do forwarding. So what is a routing? A routing is nothing but identify a shortest path between your sender network and a router's network. Via many routers are there. We are going to choose a shortest path before your data transmission to others. This shortest path may be fixed if it is a virtual circuit. Your shortest path may be different. That means packet to packet it may be different according to datagram concept. So my dear friends, a routing is done by routers. And routers are construct routing tables. So routing table is going to provide optimal path. And routing tables are going to be frequently changed if at all there is a change in the topological significance. It depends on topological significance. If topological, is there any change in the topology, then automatically routing entries are going to be changed. So these are all are there in your routing. Your routing table mainly consists of what? Source address, destination address, and your next hop router, next link. It is going to see that what is your next link and is what is the cost of that particular link to go to the receiver. So what is the routing? Routing is the process of forwarding the packets from one network to another network. Router performs the routing using shortest path, optimality principle. A router maintains a routing table to forward the packets. And a routing table mainly contains source address, destination address, next to hop or intermediate node, and what is the cost of the path. What are the functions of routing? It performs shortest path, it is using forwarding and routing decision before delivery of your data packet, and maintaining and updating your routing tables. And routing tables are updated frequently and automatically whenever there are some changes in your delays, right? They are plug and play. When you attach a new router, automatically new tables will be added. When you detach any particular router, automatically new entries are going to be formed. That means it is always sees that is there any change in your topology or is there any change in the network. Therefore, adding of new entries and removing of entries are being done automatically. And what are the properties of your routing algorithms? Because routing is done by routers are using protocols to do routing, and protocols are using routing algorithms. It is in a software mechanism. It is trying to see that shortest path, correctness, simplicity, robustness, and stability. I want to tell you one important thing. Who do the routing? Routing done by router. Routers are used routing protocols, and these routing protocols are using what? Routing techniques. These techniques are called routing algorithms, and these routing algorithms are finally give you optimal path. What is optimal path? Shortest path is nothing but optimal path. Please remember this hierarchy. So routing is a delivery mechanism from the internet layer which is try to construct the routing tables before start transmission of your data, and that routing is done by a router, and a router before performing a routing it is trying to implement protocols, And these protocols further implement mechanisms known as routing algorithms, which are trying to form optimal path for the entire session means virtual circuits. For every different packet means datagram. This is our final objective. Okay. So what are the metrics are used in order to construct your routing table? One is hop. Hop means between sender and receiver, how many hops are there? One link and another link finally goes to the destination. So here to here, one jump or hop. Here to here, one jump or hop. And here to here, one jump or hop. 3 hops before you go to the receiver. Now you see, what is a sync tree? This is impossible. Very, very important sync tree. Construction of sync tree is very important. What is a sync tree? A tree is nothing but your network only. When you see that network consists of some loops like this, when you see that network consists of loops, then there may be a chance of what congestion. Because if at all the destination is not available or any link is a failure, it keep on rotating your data packet. That's why we always want to see that a network must not have loops. It must be free from loops. So when a network or a tree is free from loops, it is called as a what? A sync tree. Very important 1 mark question. Sync tree is nothing but a network must not consist loop. The set of optimal routes from source to the destination form a tree. Such tree is called a sync tree. The sync tree consists of destination paths and all optimal destination paths. And a sync tree may not be unique. There may be multiple shortest paths are also eligible. From here to here one, from here to here one. There may be a chance of what? Multiple shortest paths will come. So a sync tree is indeed tree. Therefore, it does not contain any loops. So each packet will be delivered within a finite and bounded number of hops. This is very important. So if there is any loop means, then automatically what happened? It is trying to form a circulation. So we want to see that the packet has to be delivered at the destination at a finite amount of time, finite amount of steps or bounded amount of steps. Therefore, you are going to get acknowledgement within a finite amount of time. Otherwise, delay is going to be increased, and therefore, your acknowledgement is late arrival chances are also there. So this is about sync tree. A tree is nothing but a network which consists of a lot many optimal paths, shortest paths, and shortest paths may not be unique, and a tree must not contain any loops. You know that a tree, normal a tree, which has got some branches, but it never have a loop concept. Okay, and some are long branches, some are short branches. So short branches only we are going to use to hand over the packet to the destination. So this is your subnet. A subnet is nothing but network only. Your network consists of loops, and this we have broken. This is your without loop. What is how to do a sync tree or how to see that there will not be any loops means? For example, you see, simple answer I want to tell you. So there is a loop in this network. So this is your network consists of loops. Now, how to construct a sync tree from your network? A simple logic. What is that? Eliminate one equivalent weight. Eliminate one shortest path. That's it. If I say that this is also 1, this is 1, and if I say that this is 2 and this is 3, and if I say that this is a 4 and this is 2, so I can remove this loop. How? As their weights are different, so remove this loop. Okay, when you remove this loop, then automatically there are any loops in that. Okay, my dear friends, this is how a simple example. But you may get a doubt that, sir, it may not be a shortest path 1, 2, 3, 3, 4, 7. So how N3, how this particular router can able to find a shortest path to this? 1, 2, 3, 3 plus 4, 7, 7 plus 2, 9, 9 plus 3, 10. So what I am going to do? If I attach here, so I'm going to calculate like this. So I'm taking a 1 here only. And 1 plus 3, this I'm taking as a 4. Therefore, what happened? So you can able to remove those equal weights nodes. Therefore, it is a concept of what? Construction of shortest path. General example. So your routing algorithms are two varieties. One is non-adaptive. The other one is adaptive. Non-adaptive does not depends on current load and the current traffic and current changes. For example, you are using a Google map to start from one source to go to the one destination. So when you start map, then it will give you path, right? And when there is some traffic jams or traffic is heavy, then it is going to give you some colors also. So if you see the red color, then it is highly impossible to travel in that particular path. Therefore, it also will show you rerouting. That means another shortest path. So you can take your decision. But if you are using a non-adaptive algorithm, it won't give any kind of another paths. Once the path is established, you need to traverse in that path only. It will not show any other paths to you, even though your path is got congested, or even though you are having any other shortest paths or no traffic jams. So that is the concept of what non-adaptive. If there is any congested in that path, you need to traverse in that path only. You can't change your direction. So that is the meaning of non-adaptive. So routing decision does not depend upon the conditions of the traffic and the topology of the network. Right? You need to traverse once the path is established. So route for each possible network is computed in advance, predefined path it is. It is a predefined path. So naturally, I want to call it as a virtual circuit naturally, and are loaded into the routing tables. When the router is up, so the source asked the route, what is my path? Already path is calculated, you traverse in that. That's the meaning of it. So it forwards the packet. It is using a forwarding mechanism to deliver the data packet to the destination. It contact the router, what is my path? And the router is going to give you the path. In that path it has to go. Suddenly if you find the shortest path, router will not inform you that there is a shortest path available, because it does not consider your recent and current traffic. So it does not consider topological significance and the current load into the traffic. It is the concept of what? Shortest path. So I already shown you in the basics classes. Observe. So I'm showing you one subnet which is like this. And the sender is here. Exactly this particular router. They're all routers only, because routing is done by a router. Observe carefully, my dear friends. So receiver is available here to this network. So it initially established between sender and receiver, it initially established predefined path. The path cannot be changed during the data transmission. That is the meaning of non-adaptive. Therefore, it is saying that this is my shortest. So total your cost value from sender to the receiver, it is going via R1, R2, R3, R4 to receiver. R1, R2, R3 to receiver. What is the cost of the path? 1, 5, 6 plus 3, 9. It may be hop, or it may be a distance, or it may be a delay, because we are having a 3 different varieties of metric measurements: hop count, distance, and queue length, and the other one, transmission delay. So queue length is nothing but total number of packets queued along the path. So now I got understand that 1 and 6 and 3. So that will be the longer path to you, because it is a 10 and it is going to be 9. After transmission of few packets in that line, then this becomes 1. Then my shortest path is 1, 1, 2, 2 and 3 plus 5. So immediately, and the sender thinks that, can I use R7, R8? Can I use R1 to R7 and R7 to R8 and R8 to, what is this, router? R4. R4 finally to the receiver. What is the value? 1, 1, 2 plus 3, 5. Not possible, because already predefined path is established to you. So whenever predefined path is established, you cannot change the path. So because it is following a concept of what? Non-adaptive. So adaptive means this is possible. If you are using adaptive algorithms, it consider topological sequence. Every particular packet is going to be treated as individual unit, and it try to give you the routing table for individual packet, not for the entire message. So they collect the information about the state of the network and make routing decisions based on the latest information, latest delays, or latest distance, latest length, qubit packet. So it considers topological significance and current load while calculating the routing path. You can change, you can go like this. Google Map is following adaptive routing only, because when you find a congested path, immediately it opens another path for you. You traverse in this side, this will be the shorter to you. So you can go in that side. If you feel that that is busy, you can go this side, you can go this side, because it's not a predefined path. The path is established dynamically. That's why it is called as a dynamic, also called as a forward. And in non-adaptive, you call it as what? Session routing as well as a static routing. Okay. So according to routing, routing is nothing but contact your routing table and take the path, forward your packet for the delivery to the destination. That's the meaning. Okay. There are two varieties of routings are there. One is interior gateway routing. The other one, exterior gateway routing. What is interior gateway routing? The routing within the autonomous system or a subnetwork. Exterior routing means what? The routing between two different networks or two different autonomous systems. This is internal. Interior gateway routing, exterior gateway routing. This is external, also called as exterior routing. Exterior routing. This is called interior routing. What is interior routing? Routing within the subnet, or within the WAN, or within the LAN, or within the autonomous system. This is a right term, autonomous system. What is exterior routing? Among autonomous systems. Okay. I will show you what is autonomous system. Please hold on. Please observe carefully. Autonomous system I am showing you. Your entire internet is a worldwide, I am talking worldwide internet, cannot be managed alone. Therefore, it is being divided into hierarchy. That hierarchy consists a group of routers which are collectively involved in order to do data transmission from one network to other network. So when you form group of routers together, it is an autonomous system. When you form group of routers together, it is autonomous system. Now here also your internet is a divided hierarchy. I am following hierarchy in internet. This is how it is happening nowadays. Internet is first divided into country wise. Then country is divided into state wise. Then state is divided into district wise. District is divided into mandal wise. So we are following like this only. So router and another router, another router, another router. Assume that this is a one state, this is another state, or one country or another country. However you guess it. But there are two different autonomous system. Group of routers when you form together, which are part of your a large network. It is a concept of what? Autonomous system. Now you see, numbering I am doing. Router 1, router 2, router 3, router 4, 5, 6, 7, 8. Now internet is divided into two particular autonomous system. R3 would like to post data to R2. Yes, I can post it. R3 belongs to same autonomous system now. I am using what? Interior routing. And here R7 would like to communicate with R6, district to district or state to state, whatever it may be. So here also it is using interior routing only. My dear friends, what is interior routing? Routing within the autonomous system, communication within exchange or communication within your state or a country is called as a autonomous system, interior routing. Now, this autonomous system with the help of internet wants to communicate with other autonomous systems. So therefore, this autonomous system is trying to communicate with other autonomous system. Then you want to have communication like this. There is a requirement of exterior routing. So exterior routing is done the routing between two or more autonomous systems. Okay. Now, if you want to use interior routing, what is interior routing? Routing within autonomous system. Routing within autonomous system. So you want to use interior routing, you supposed to use core routers. Core routers. And the core routers are going to use interior gateway routing protocols. Let me write completely. Interior gateway routing protocols. Interior gateway routing protocol. Okay. What are interior routing gateway protocols? There are two famous protocols. One is a routing information protocol. The other one, open shortest path first. These two protocols are mainly for what? Within autonomous system only, or within a subnetwork, or within a network. Right? So please understand these three important points. 1, 2, and 3. And next one is exterior routing. When you talk about exterior routing, routing among autonomous system, okay, you want to use exterior routing, you're supposed to use a border routers, also called as area routers. Area to area you are communicating. That's why those routers are different. Router is hardware device. Earlier case, you need to use a core routers, and here you have to use a border router. Special, they are very special routers which are trying to communicate among autonomous system to among autonomous system. You can have such kind of configuration mechanisms in that. Okay, and border routers are going to use exterior gateway routing protocols. What are exterior gateway routing protocols? Let me write completely. Exterior gateway routing protocol. There are two varieties. One is exterior gateway protocol, border gateway protocol. These two cannot be used in interior purpose. These two exclusively for exterior and those two exclusively for interior only. Okay, so that's the meaning of this. Is that routing protocol categories are interior routing known as intra-domain. Exterior means inter-domain, internet, inter-domain. And routing protocols are separated. Intra-domain is nothing but interior routing only. I am using what? Two different protocols. What is it? RIP and OSPF. And inter-domain exterior routing I am using. When you use exterior routing, then it is a protocol called BGP. Earlier we are having exterior gateway protocol that is replaced by BGP. Okay. So my dear friends, I already told you, please observe carefully. The diagram we will see now. What is the diagram? This diagram. So they are all your core routers only. If you feel that this is a border router, if you feel that this is a border router, this border router can able to communicate from one autonomous system to another autonomous system. And the rest are going to be core routers only. Okay. Now let us learn the types of autonomous systems we are having. The first variety of autonomous system is called stub. The next variety of autonomous system is called multi-home. So what is a stub? What is a multi-home? So the stub autonomous system is nothing but this router 1 can communicate with router 2. No problem. Direct link. But you cannot use it as a bypass. You cannot use it as a bypass. What is a bypass? I say R1 I am using as intermediate route to send the data to R2. So you cannot use this. So point to point dedicated links are required here, and that too only 1:1 connectivity. So one router can able to connect with other routers, multiple paths cannot be established. The second variety is multi-home. What is a multi-home? This router can R1 can have multiple inputs, and router R1 can have multiple outputs. That means it can get data from, that's what the meaning of multi-home. It can data from any kind of input routers. It can also hand over data to any kind of multiple routers. But stub means it's a point to point. It is a multi-home. So multiple inputs and multiple outputs. But here it is only one input and only one output only. But what is the problem here? Here also you cannot do what? Bypass. So this is how the autonomous systems and types of autonomous system we are having. So we will meet in the next session. That is I want to discuss according to your syllabus distance vector routing and its problems count to infinity that we are going to do in the next session. So stay tuned to Unacademy and stay tuned to Srinivasarao Sir classes. Please you revise this lecture once again because as a new things are there. One more autonomous system I will tell you. What is that? We have learned only two, stub and multi-home. One more is there, transient. Transient autonomous system. What is a transient autonomous system? You can also use it as a bypass also. It is the combination of multi-home plus multi-home do not have bypass, but it is having a what? Bypass concept. Okay, so transient. So please learn these different varieties of technical terms. So we will meet in the next session with the distance vector routing. Don't miss, please. So we will learn distance vector routing in next session. Use my referral code to get the admission into Unacademy. Stay tuned to me. Thank you very much for spending your valuable time. Please do like my video. Give comments, please.